So few people think that HVAC is all about luxury, waste of money and valuable energy. But is it true? No. Few people think that HVAC. But of course, it is the right of every individual to live in comfort, and HVAC is committed for it also. And this HVAC serves the industrial segment to a greater extent. So if you see in previous years, if you see this HVAC air conditioning would be only with top or posh people, rich people. Now is it the same? No. Now even a common people has the air conditioning in it. And if you see the HVAC is the national building industry. And it is now told that HVAC is no longer a luxury, and it is a part and parcel of everyone's life. So it from a small man's house to a rich man's house, you can see a AC in everyone's house, and it is become a part and parcel. That is, it is now become not a luxury, it is a common thing which everyone enjoys it. The states are very happy in HVAC and R as the system consumes close to half the connected electric power. It is told that generally if you are using an air conditioning, ventilation, air conditioning systems, the electric power load is very high. That too, it can be a minimum for household articles. But if you see in industries and other things, it is told that nearly 50% of the electrical energy consumption is because of this air conditioning and ventilation. And that too, if you go to any nuclear establishment like us, it is more than 55 to 60% of the electrical energy. This system consumes more than 55 to 60% of this electrical energy. So if you see what are the various applications of air conditioning, so various where and all you can see is that in the shopping malls, auditoriums, theaters, hospitals, hotels, restaurants, offices, commercial complexes, luxurious apartments, IT parks, pharma industries, telecommunication, and you name anything. Now air conditioning is always there in these buildings. So generally, if you see what is the definition of an air conditioning, if you see air conditioning can be defined as the process of treating air so as to control simultaneously its temperature, humidity, cleanliness, and distribute air to meet the requirement of the conditioned space. What it means is like what you are doing in air conditioning is like you are controlling simultaneously the temperature. What is the temperature you maintain in air conditioning system is 25 plus or minus 1 degree. And humidity will also be maintained. How and what is the humidity level? If you see it is 55 plus or minus 5%. The humidity levels are maintained through strip heaters in the air handling units. And we have to, whatever air we give to the rooms, it should be clean. How do we ensure this? Is by means of filtration. The air, whatever we air supplied to the rooms or space, it will be cleaned with the help of filters and distribute. And these air should be distributed equally or to meet the requirements in each room so that you get the required air changes. So all this together is air conditioning. Okay. Next. So generally you are telling about air conditioning. So if you want to install an air conditioning in a house or something, how do you specify it? It is basically in terms of TR, ton of refrigeration. So if you want to install air conditioning in one of your house rooms in a house, so you tell that I need 1 ton of refrigeration, 1.5 TR, 2 TR. So what is that TR means? TR means it's ton of refrigeration, and it is the amount of heat required to melt 1 ton of ice at 0 degree in 24 hours. This is basically the definition of ton of refrigeration, and 1 TR is equal to 12,000 British thermal unit per hour, BTU they say, or it is 3,250 kilocalorie per hour or 3.5 kilowatt. Various units it is available. So this is basically the TR. So if you see in the basic air conditioning, there are basically 4 basic components in an air conditioning system. That is the compressor. It is called the heart of the system. Then we have a condenser. We have a throttling device. Sorry. Then you have an evaporator. These are the 4 basic components in an air conditioning system. So if you see the air conditioning system works on the vapor compression cycle. These are the 4 components. You can see here it is the compressor. You have a condenser, you have expansion device, and evaporator. Basically, you provide energy in the compressor. In the compressor, what comes is the high temperature, high pressure refrigerant in the form of vapor comes to the condenser. where heat is rejected and the refrigerant gets converted into high temperature, high pressure liquid. And when it passes through the expansion device, it gets converted into low temperature, low pressure vapor liquid, and it goes to the evaporator. Once it is going to evaporator, then it is getting heat is being taken in, and then the gas again goes to the low pressure, low temperature gas goes to the compressor, and the cycle continues. This is the basic refrigeration cycle, vapor compression refrigeration cycle that is generally happening in a air conditioning system. If you see the various air conditioning system, it can be divided into non-ducted products and ductable products. Under ductable products, if you see, it is split AC or window air conditioners. Under split air conditioners, you have, based on the type of mounting, it could be either floor mounting, wall mounting, or ceiling mounting. You have the various types in a split AC. And this ceiling mounted could be a cassette type or highway type or exposed type, any type based on the type of mounting. And again, if you see in the type of ductable systems, we have package air conditioners and central plants. So these package air conditioning could be of floor mounted type or air conditioned splits. So even these two could be again subdivided into air cooled or water cooled. Under central plant, if you see, it is either DX type or chilled water system. So chilled water DX is nothing but the refrigerant based, and chilled water system is we produce chilled water using the refrigerant, and this chilled water is used to sent to various air handling units. And under these two types, we have again vapor compression or vapor absorption. And under vapor compression, based on the type of chillers, we have reciprocating chillers, then centrifugal, screw. And in terms of vapor absorption, it can be either hot water fired or direct fired or steam fired. Based on the application, it could be either type. These are generally basic various types. So under another type is the type of air conditioners based on application or size. If you see, it can be either unitary based or centralized AC plants. Under unitary based, it could be either window room air conditioners. Generally, if you see in markets, it is available from 5 TR, 0.5 TR to 2.5 TRs. Again, split air conditioners, it is available from 1 TR to 2.5 TRs. Ductable split air conditioners are available from 3 to 15 TR. Floor mounted package units are available from 5 TR to 20 TR. Then the latest ones, energy saving aspects now has come into systems, and these are inverter based or VRV or VRF systems. It comes from 10 HP to 100 HP. These are now latest model systems where all the energy conservation aspects are inbuilt in this. Then another for higher capacity is chilled water system, and we have scroll chillers ranging from 11 TR to 100 TR, and screw chillers from 50 to 500 TRs. These are based on the application and sizes. So generally we'll go about the basics ones. Type of air conditionings. These are window air conditioners, split air conditioners, package air conditioners, and central plants. So these are the images, split window and package air conditioners. We'll see about window air conditioner. Window air conditioners are one of the most commonly used and cheap type of air conditioners. You can see the pictures here. Window air conditioner units are reliable and simple to install. You do not need any separate equipment or things. If you have a window and a window opening, you can install this, and it doesn't require any complicated systems or anything. So it is a complete box type unit where you can cut open a window and install this, and your all problems will be solved, and your room will be cooled immediately. So this is the cut section of an window air conditioner, where you can see you have a compressor here, you have a evaporator coil, then you have condenser coil, you have outlet grills, control units. These are the various systems available in you have a blower, and these components all together work to provide the necessary cooling in rooms. So if you see the section and plan elevation of a window air conditioner, this you consider this to be a wall. If the unit will be placed in such a way that half will be towards the room and half will be outside the room. Now, outside will be the condenser coil, and inside will be the evaporator coil, and in this all the process will be taking out, and you will be getting the chilled air to the room through this evaporator coil. This is the basic operation. So next, if you see about split air conditioners. Split air conditioners, it is basically the split air conditioner comprises of two parts. the outdoor unit and the indoor unit. The outdoor unit is fitted with the room outside the room, and it houses the major components like compressor, condenser, and the expansion valves. And the indoor unit has the evaporator coil in it. So if you see, this is the how and split air conditioners are installed. This is going to be the room where you erect the indoor unit, and the outdoor unit will be placed outside the room, and the both will be connected through the refrigerant tubing, will be connected through copper pipings. And the major advantage of split AC is that the noise level will be less, because this outdoor unit, the compressor and things are let outside, is fitted outside. So there will not be any noise. This is the major advantage of a split AC. So next level of this thing is called as package air conditioning. And if you see about the package air conditioning, the window and split air conditioners are usually used for up to a smaller capacity, up to 3 or 5 TR tons. If you want to go out with still higher capacities, the package air conditioners are used for cooling between these two extremes. So that is the major thing in the package air conditioners. And this again repeating. So if you see, this is one of the package air conditioning where the range ranges from more than 5 TR to 20 TR. You have this package air conditioners. It is ductable unit where the unit will be placed in a common room or outside, and from this unit all the ducts will be laid, and through this duct the chilled air will be passed through, and it will be cooling the various rooms in the building. So next level is the central air conditioning units. So what happens in a central air conditioning unit is that when the demand for air conditioning is huge, if you have wanted air condition for 1 or 2 rooms of 1.5 TR or 2 TR, we can go for this normal window or split air conditioning. When the demand is huge and you have to air condition for more than 15 rooms, 20 rooms, 100 rooms, and the air conditioning loads are high, then what we do is we go for an central air conditioning system where we will have a chiller, and through this chiller we will produce chilled water. And this is the example drawing you can see here. Actually, we will have a chilling plant. With the chilling plant, we will produce the necessary chilled water, and this chilled water will be pumped through pumps to the air handling units. Where the air handling units, the air will be cooled because of pumping of this chilled water, and the chilled air will be sent to the various rooms. Like if this is going to be various rooms, it will be supplied to these ducts, and air will be this chilled air, cool air will be supplied to the various rooms, and this is how air conditioning is done in a centralized air conditioning system. So I said about chiller plants. So in chiller plants, generally what we have, 2 types of chillers are available. One is air-cooled chiller and water-cooled chillers. Based on the application, type of capacity and availability of water, we can go out with selecting either air-cooled chiller or the water-cooled chiller. So in this chiller, we have to use refrigerants. Generally, previously, what refrigerants we used was that it used to be R11 or R22. These used to be an CFC refrigerants. Nowadays, because of this chlorofluorocarbons and emission and other things, now what government is coming out is with eco-friendly refrigerants. And these eco-friendly refrigerants are, some of the refrigerants are R134A, R123, R407, R410, and R22 is now under the phase-out condition. By 2030 or 2040, it will be phased out. And then we'll be all using only the complete eco-friendly refrigerants. So next, I said about the compressors in the chillers. So these compressors also will be of various types. They also range from reciprocating type, rotary type, scroll type, screw type, centrifugal type. These are also based on their application and type of tier, whether it is going to be higher load or the type of thing. We select these types of compressors and it will be used. So here are some of the photographs. Reciprocating type, these are scroll type, rotary types. Then you can see the screw and centrifugal type available. So next is the commonly used equipments in air systems. In air conditioning systems are air handling unit. This is the unit where heat exchange takes place. That is generally what happens is chilled, we'll have a coil here. Chilled water will be supplied to the coil, and air will be through blower, air will be passed through the coil, and because of heat transfer, air gets cooled, and through this air handling units only, the chilled air will be supplied to various rooms and things. Generally, what the air handling unit is will be of higher capacity, more than 30 TR, 20 TR, we call this air handling unit. And if it is going to be for small rooms, 1 or 2 rooms, and it is going to be 1 TR, 1.5 TR, or 3 TR, we call it as a fan coil unit. And we will have various cooling towers for our condenser cooling purposes. These are the equipments. Okay. Next, if you see, I said we'll be using chilled water or condenser water. To move this water from one location to another, or one circuit to another circuit, what you need is a pump. These pumps can be of either type, it can be of monoblock, vertical split casing pumps, horizontal split casing pumps, then inline pumps. So based on our application type of things needed in the erection, we select these types of pumps and we go out with installing this. Basically, these pumps will be catering to the condenser water and the chilled water requirements. So once chilled water side is over, next is the ducting. The chilled air, whichever is now produced in air handling unit, have to be sent from one location to another location. I said this can be sent through means of a ducts, and these ducts could be either factory fabricated ducts or site fabricated ducts. What is factory fabricated duct is like, these ducts will be fabricated in a factory. In factory, we'll be having the cutting machines, bending machines, then fabrication machine, everything will be available. So if we give the sizes, based on the size, everything, they'll be cutting it in the machine itself, then folding machines are there, then all the things will be happening inside the factory, and after fabrication of the factory, this will be transported to the site, and through bolt and nuts arrangement, they will be erected. It is basically a time reduction process, because once it is all ready, because once design is ready and it's all fabricated at factory, it can be brought to the site and erection is easy. That is the major advantage of factory fabricated. In some cases, some dimensions could be taken only at site. So in that cases, what they do is they bring the sheets and everything, make the fabrication at the site and connect the things. Then these are the ducting accessories, because once what happens is through ducts, the air will be coming, and at the terminals or something, we'll have to have some accessories which allows the air to pass through. These are called as duct accessories, and they are called as grills. There are various types of grills are available. It is adjustable grills, then linear grills, then linear diffusers, then slot diffusers, square or rectangular diffusers, round diffusers, then collar dampers. In the ducts, we will have dampers to divert or to regulate the flow. Then duct dampers are available. Then VAV, variable air volume dampers. Various dampers and things will be inducted in the ducting system so as to regulate the flow. Next, if you see the types of grills and diffusers, I said no, the terminals. These terminals could be of continuous grills. Generally, what we do is these continuous grills will be used in the return airlines where you don't need any regulations. So these we use continuous grills. Then we have linear grills, adjustable grills. We'll have damper inside to regulate the flow. Generally, what happens is that if a room, we have to provide around 10 cmh of air. 10 cmh means 10 cubic meter of air is to be supplied, means then we'll have this size of this damper. If this size is around 750 by 150 means we'll have the size area we'll be calculating, and we'll have based on this deflection, the supplier gives a constant factor. So this area means 750 into 150 is the area into, they'll give a multiplication factor based on the type of grill. If it is going to be 0.8 means we'll multiply with 0.8. That is the area of the grill. If we know the area of the grill, and if you have an anemometer to measure the velocity, it is meter per second, means if you measure both, you multiply both, what we get is the flow. This is how the flow is being measured in a ducts, in a grills. Then we will have a diffusers. Based on the need, we go out with the grills and diffusers. Then I said this either in a chilled water will flow through pipes. If it is going to be a chilled air, it passes through ducts. So in both the cases, we are passing chilled air or chilled water, because once it is passing from one location to another location, generally what will happen is there will be some losses. because, and the temperature when it's starting, if it is going to be at 10 degrees centigrade, chilled water is flowing at 8 degrees. At tail end, if you go, the temperature will increase because of losses and other things. So to minimize this losses, what we do is we have the insulation. There are various types of insulation available. Previously, in olden days, what they used to do is they used to have a thermocol with cement plastering. They used to have bitumen tar. They used to melt it. On this bitumen tar, they used to put it on the pipe. Then they used to have a thermocol wrapped on it. Then as a barrier, what they do is they'll roll a plastic sheet and tie it. Then they put a chicken mesh. Then they do a cement plastering. This was all the old method of insulation, which was time consuming and not so effective. Now latest, there are many insulation materials coming in. Like you have these are old thermocol. Now expanded polyurethane is there. Puff foams are available. Then fiberglass wool, nitrile rubber, rock wool, various insulation materials are available. And these materials, if you see, the latest one is the polyurethane foam sections. That is puff, they say. That is basically done with the help of two chemicals called as isocyanide, polyisocyanide and polyoil. If we mix these two, then an insulation will be formed, and this is nothing but the polyurethane foam section, where the thermal conductivities are very less, and these types of insulations are nowadays very much used. Next, if with this we'll just I'll come out of the basics of HVAC, because in basic of HVAC we have touched upon what is air conditioning, what are the various equipments used, what are the pumps, what are the ductings, what are the ducting materials, what are the insulation pumps, everything we have seen. Now we'll go into ventilation. So what is ventilation means? Ventilation is the process of changing or replenishing air in a space to provide high indoor air quality. That is, if you have a room of volume 1 meter. Hello? 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 Hello?
Mohan, sir.
Audible, sir?
Sir,
Audible, sir.
Yes,
Okay,
sir.
Okay,
Your
okay.
voice is very low, sir.
Hello? Now, sir?
Yes, sir. It's clear now.
Okay. So in ventilation, basically, it is the process of changing or replenishing air in a space to provide high indoor air quality. That is, indoor air quality means that it should not have more of carbon dioxide. We should have, because any person in a room, if he is there for too many long time, what he takes in all the carbon oxygen and leaves out carbon dioxide. If for more than hours he is to get sitting in this room without fresh air, what he'll have suffocation and things. So ventilation plays a major role in these types. So that is the major purpose of an ventilation in a normal. But in a radioactive field, ventilation is much critical, and we'll see about it in the coming slides. So generally, if you see, ventilation means it is of two types: positive pressure ventilation or negative pressure ventilation. What happens is, positive pressure means induces fresh air into the confined space, resulting in an increase in pressure of that area. If there is a room and if you are supplying air from outside to inside and thereby pressure increases, means then it is called positive pressure. This allows air to move from inside to outside, because once the pressure inside is more, what happens is air can come out. This is positive pressure. Whereas another thing is negative pressure. Generally in radioactive ventilations, we go out with negative pressure ventilation. What happens is we exhaust more quantity of air than supply. If we are supplying around 10 cmh of air to a room and exhausting 13 cmh of air, what happens is that there is a negative pressure created, because we are exhausting more. Thereby a vacuum is created, and in these types of building, what happens is that fresh air is allowed to enter from outside to inside. So inside air will not go. So this is how a safety is ensured in a radioactive building. I'll just tell about this in further slides also. So if we have been telling about nuclear facilities, my presentation basically this safety aspects in nuclear facilities to bring in the knowledge to the young students, because now you know that the energy demand in present world, the demand is hugely increasing day by day, and with the conventional sources of power production, we will not be able to meet the energy demand. So because the coal or whatever source is available, it is getting exhausted. Now we have to go with alternate source of energy, like we have to go with solar, tidal, and one such energy is the nuclear energy. Nuclear energy, the energy output is very high compared to others. So we have the only way to sustain the future demand is one of the major way is nuclear energy. But what happens is like there are a lot of oppositions from general public. You see Kudangalam, when it started commissioning people, there are a lot of people in the township or on the village opposing the nuclear establishment because they did not know the pros and cons, because they were all afraid that because of operation of this nuclear system, their soil may get the radiation or some, they are having lot of inherents. So the basic to all the fear will be cleared only if these types of lectures are arranged. Because if you see for a small nuclear in a nuclear reactor or nuclear facility for air conditioning, what I'm going to tell the safety features. If this levels of safety is to be introduced, then if you can think of the radiation nuclear facilities, what are the level of safety will be incorporated. So people have to come out of this setup, because now there is no other go other than nuclear facility, because with nuclear only we will be able to sustain the energy for future. So I'll tell in detail in the how these are being carried out. Okay. So if you see in a nuclear facilities, what are the hazards? It could be normal hazards. Normal hazards due to smoke, fire, chemical, or other. Other thing, it could be radiation hazards. It could be internal or external radiation hazards due to alpha, beta, gamma rays and neutron activity. Because of radiation, there could be some radiation level decrease, release. So how we are going to control this, we'll all see in the subsequent slides. The other is the uncontrolled nuclear fission. This can occur only when fissile materials are brought together in excess of a particular critical quantity. This is an exceptional case where all safety will be there to not to happen this. Okay. So in any nuclear establishment, the radiation protection plays a major role. In any building or nuclear building, the facilities and its components should be designed to maintain ALARA principle, exposure to radiation from radioactive material to both plant personnel and to members of the general public. The major main advantage or main design criteria for nuclear facility is that whatever design, or I'm going to use a radiation nuclear establishment, because of this operation of nuclear facility, it should not affect the person working in the plant, not only in the plant, but also to the general public. If Kalpakam is the one nuclear establishment, it should not affect the persons working inside the lab. I am working in a nuclear establishment. It should not harm me because I am in a nuclear field. It should not, because it can happen sometimes that I am in a nuclear field, it can affect me. But general public nearby Kalpakam, there are Pudupatnam village, many villages are there where they are general public, they don't know anything about. So our design should be in such a way that it should not affect the person working in the factory and also to the general public. How this is ensured is basically by a principle called as ALARA. It means as low as reasonably achievable. So how do you do this? Means it is basically the TDS principle. They call as time, distance, and shielding. Time means if there is going to be a radiation exposure in a particular area, what we have to do is, if some work has to be carried out with same of safety aspects, it has to be minimized. If work has to be carried out in a radioactive environment, with all safety precautions, a person will be allowed to do for a very short duration. We have to plan to carry out the work in minimum duration, because these areas radiations are there. So that is the first principle. Second thing is distance. Wherever possible, we have to work from the maximum distance from the source. If there is a radiation source in one location, wherever possible, we have to work from a distance. Whatever equipments that are needed, that can be used. So that is the second principle. Third, that is also not possible, means the thing is next one is called as shielding. Maximum shielding to minimize the dose. If you have a radiation source and this radiation source should not pass through one location to another location, then we have to have a shielding. This shielding could be a stainless steel, lead, concrete, various shielding materials are there. If we have a partition of these materials, then this radiation doesn't come from one location to another location. This is the general principle followed in a radioactive systems. So I said about nuclear ventilation system. So what are the various concepts in designing of a nuclear ventilation system? If you see, It is basically once through ventilation system. We'll see about all this in subsequent slides. So first one is once through ventilation system. Then we will have multi-zone ventilation system. Then we will be having containments or enclosure to handle the radioactive materials. Then these areas